Good morning, everybody. Now, I understand on the schedule, it may say that we have a Q&A day, but if you've been paying attention, you would realize that we didn't quite finish our division examples. So that is what we will do today with some time left, I hope, for questions or whatever might come up. Um, I had to change my setup again, so can I just maybe get confirmation from someone that you can see and hear me and that everything on the technical side is good?
Looks good.
Yeah, everything sounds good.
Perfect. All right. So, whoopsie, no, not full screen. Let's see here. Zoom out a little. There we go. So we did the first division example. We have to definitely have some mixed numbers. But let's start with number 2. Actually, number 2 is a tough one too. Let's start with number 3. I don't think we should really be cheap in this one. Oh, hold on. I think we should do them all because division is tough. Hold on. My tablet is on the wrong screen. 1 second. Work area, switch. There we go. With division, yes, it's luckily not like multiplication where there are sort of 2 versions, but some people get a little flustered when, no, I said not 2 first. I will do 2. We have to do 2. Some people get a little flustered when they see different size numbers in the division. Sometimes the first is bigger, sometimes the second one is bigger, and it feels maybe coming from multiplication that they should do something differently. That's not the case here. Luckily, there's only one way of doing this, depending on, of course, the exact sentences that you're writing. So we have an amount. Remember now the first number in this division instruction is how much I have. So I have quite a bit. So that's nice. It's definitely more intuitive to see a substantial amount that I can work with. So let's draw that. Don't want to make them too small. Don't want to make them too big, but enough so you will have space to draw and fit stuff in. So I'm gonna, of course, realize that. Ooh, that was nice. That's a nice pink. It's a nice pink. I have the whole first 2 whole rectangles. So at this stage, I see no need to break them up. Of course, with enough experience, having done some examples, I know I'm going to have to. But in the case of addition, I didn't. So it really depends. Definitely splitting up the last one into 4 slices. And then one of those slices is what I have. Okay, great. That's quite a bit. Nice. I like it. Now we have our group or group size is 2/3 of a whole rectangle. Not of what we have, just group size. So I need to figure out, well, what is this? How many pieces am I looking at here? So for that reason, I need to bring in this denominator as well. So 3 slices horizontally. No, no, that's not going to be in the middle. Like so. Because I just need to see a rectangle. This has got nothing to do with pink. I just need a standard rectangle split up in this way so that I can see, well, 2/3 means 2 of 3 rows. That means my group consists of 1, 2, 3, 4, 5, 6, 7, 8 pieces. Those pieces aren't pink, they're just pieces. So that's going to be my group size. Now when I look at what the instructions want me to do with that group size, which is fitting it into the pink, now it matters what I actually have. Now because I'm going to see how many times can 8 pieces fit into the pink that I have, I of course need to split the others up as well. So everything needs to look the same. I need to see those pieces everywhere. So for that reason, I do have to split the first 2 rectangles. So let's do that. Let's do that. Try and make them equal, sort of. And then horizontally. The more I have, the more lines I have to draw. There we go. Okay, now I'm ready to do my fitting. So let's get fitting. Now again, you can take sort of the lazy approach and say, just count how many pink pieces I have, divide that by 8, and then, like usual, I convert my fraction calculation to an integer calculation. It's not wrong, but it feels a little detached. And with the goal of going as intuitive and basic as possible, I have a drawing. Why not go all the way? 8. I can fit 8 in here like so. That's once. Then I have 4 over here. And let me make it T. That would be 8. That's another time I can fit them in. Doesn't matter how. 2, 4, 6, 8 over here. That'll be 3 times. And then I don't have enough left, right? I do have some left, not enough. Okay, so let's write that down. So color is always going to be better. Drawing is always going to be nicer at this level. So blue, well, in a way, sure. We can fit our groups, our group size, however you want to say it, into what we have 3 whole times with 3 pieces left over. And of course, if you did, how many squares did I have? I don't even know. 1, 2, 3 rows. 1, 2, 3, 4, 8, 9. So 27. 27 divided by 8 is 3 with a remainder of 3. But I think this is nicer. Okay, so my answer therefore is going to be, not pink. My answer is therefore going to be, I can follow the instructions, doing this fitting in of groups 3 times with 3/8 of a group that I can account for, or 3/8 of a time more, however you want to say it. That is my answer. And we are done. So when it comes to the division presentation, it's actually, there's more thinking, more understanding involved, that if I didn't think about this beforehand, I wouldn't know what to do. But in terms of the sentences that I write, it's actually less. I'm a little disappointed now. Because my reference denominator, so to speak, is already done. It's the group size. I don't need a standard sentence like I have in the past because my answer isn't in reference to a standard rectangle. So it's a different kind of concept. So I actually write very little. So definitely don't go cheap on the writing, but make sure that we show what we have. A lot of what we did is in diagram form, so that cuts out some sentences. Then I write down the results of our fitting in, and that leads me directly to the answer. So it's a little short in the presentation, but still we didn't uh, skip any step, making the jump too big. The drawing is a bigger part of it than usual, and I think that's maybe the reason. All right, see it all. So the most intuitive one, okay, so we see that the first number can be a mixed number, it can be large, can be small, whatever. It's about the second one, fitting that in to what I have. However, it does to some people feel a little strange if I have a very small first number. So let's have a look. I'll now go back to number 2. Number 2 is 1/5 divided by 2/3. Now, yes, the second number can be big. We'll make it big later in number 4, but it's bigger than the first one. Doesn't change what I do. I still have my first number's quantity. It's just not a lot. Not a lot. Split it up into 5 slices. Sort of equal. I don't think I did a very good job in making them equal. My last ones are always a little bigger. And we only have one of those slices. So sad. Not nothing, but it's not much. All right. So now, understanding what the division is instructing me to do, I need to look at group size of 2/3 of a, oopsie, a whole rectangle. Let's emphasize rectangle. That means 2 of 3 rows. Oh, it's 2/3 again. Oh, I'm sorry. That's not very original, but we're already in it. So I split it up so that I can see, I need to see 2 of 3 things. Columns are done, rows it is. So that means that my group size in integer form is 1, 2, 3, 4, 5, 10. 10 little pieces. All right. Now the instructions tell me to fit a group of 10 as many times as I can into what I have. We can fit groups, let's say, of 10 pieces into, I'll emphasize, what we have 0 times. No whole times, if you will. With 3 pink pieces. I'm loving this pink. It's not as bright, it's nice. Left over. Left over. So it bothers people perhaps that I can't even fit it in once. I really want to. And yes, this is not the intuitive, well, this is not the example I would start with to build a number sense. I'd like to actually accomplish some fitting in, but this could definitely happen. So that's all we can do. My answer is therefore, I'm not going to write the zero in the mixed number. I couldn't fit it in at all. I just have left 3/10 of a group, and that is it. So how much of the group can I fit in? 3/10 of it. I have 3, but I need 10. And it's because I didn't have enough to start with. 2/3 can't fit into that. So how much of it can fit in? It's not obvious to me. We draw a picture and try and figure it out. 3/10, it turns out. So this one does feel a little bit strange, and I don't want to do these for my first examples, but they can definitely happen. What feels even worse, perhaps, is when the first number is smaller and the second one is even bigger. So let's see what could be, I think, the worst case. 7/8 divided by 1 2/3. But nothing changes. I have an amount corresponding to the first quantity, 7/8. I'll split it up according to eighths. Half and half. Half. No, not like that. Half of a half. Oh, that half's a little small. Of a half. Of a half. And you quickly see why I don't really want to go past 8. I don't think we have any problems going past 8 either. Luckily, I have a fair bit of it. 7 of the 8 slices. It won't be enough. But I don't know that at this stage. Okay, I seem to have some, so we're feeling optimistic. Now, our group size is 1 2/3 of a whole rectangle. Of a whole rectangle. This is a little different than what I have before. So in order for me to figure out how much this is, I need to see more than just one rectangle. I don't have that many because the first number wasn't big enough to justify it. But the second one is. So it's not going to be pink, but I need to see another rectangle. To make sense of how much is this group size? Oh, it's a lot. So I'm going to have to go eighths and just set it up. Not annoying at all. So because the numbers are a little bit out of whack, it feels to many people that I need to do something different. And if I haven't thought about this to realize it's exactly the same, I might not know what to do. Okay, so it's not going to be pink. I just need to set up another rectangle because the group size is one whole rectangle and then another 2/3 of a rectangle. But same as before, I need to split it up sideways into 3, right? So let's do that. Thirds. Here we go. Here we go. And there we are. So now I can see, okay, this means one whole rectangle has 3 rows, and then 2/3 of another one, that's 5 of the rows. That is a whole bunch. 5 rows. Each row contains 8, right? So we have a group size of 40 pieces. 40. That doesn't seem right, but it is. It is correct, and it's because that second number is so big. So now, the instructions are telling me to see how many times I can fit a group of 40 pieces into what I have. Let's at least write that down. We can fit groups of, my F is always a little not curly, 40 pieces into, emphasize, what we have. Well, as I suspected originally, no, my group size is too big. I don't have enough. You can double check. I have a row here of 7 pink ones. 3 times 7 is only 21, right? So no whole times, just to emphasize, with all 21 left over. And those 21 are pink. 21 left over. Left over, as I suspected. So, the question is simply then, what is my answer for the number of times I can do this fitting in, or how many times I can fit a group in, how many groups can fit in, or whatever wording you want to use. I can fit in 21/40ths of a group. Can't even get a whole group in. I can get a little portion of a group. Approximately half, but it's not exactly half. And that is it. When you understand what the division is asking, and you have figured out how you want to lay out your answer, it doesn't matter what those, what the sizes are that you're working with. Doesn't matter. The fitting in is the same. It's just a matter of doing enough to clearly show that you understand what the instructions are, and then just doing it and understanding there's no difference in the method based on the sizes of the numbers, only for multiplication. There's a little bit of an intuitive difference, I'll call it. Intuitive difference. Alrighty. Any questions on that? Any questions on that? It's just a matter of practice, practice, and practice. Now, the one thing that, to be honest, I'm a little hesitant to talk about because I think people misinterpret what I'm saying, but that's not really my fault, is where this takes me eventually in my introduction of fractions. So remember, as I have numbers that are a little bit inconvenient, they're not small anymore, I have to slowly drift away from this intuitive understanding of, in this case, fraction calculations, right? Keeping things as basic as I can only works when the numbers are convenient enough for me to draw stuff. If I have unpleasant fractions like I don't know, 17 over 53. Who on earth wants to draw a rectangle anymore? No, I have to drift over here and see. Well, my initial understanding, I just have division examples right now. My initial understanding of the arithmetic involved and the process on a basic intuitive level, can that lead me to discover properties that are true in general? Now, as a teacher, I'm using inductive reasoning, and of course, I know the risks, but we can still use these examples to spark that thought like, oh, there has to be a faster way to do this. I'm eventually, as little Timmy, going to get sick of drawing these rectangles, especially when the numbers are a little bit less convenient. Surely there's another way. And that's totally fine to ask that question and to want to be more efficient, but it should happen after this. So because we have the time, let's just go through and see, because it's not necessarily obvious for everyone and for each of the operations, how we can use this basic approach to suggest how to handle the less convenient numbers. Now, in the case of addition and subtraction, let's just take something small, right? Let's just take a quarter plus, I'll start with a plus, let's say 2/3. Actually, sure. Now, I know what to do here. I start with my first number. That's what I have. So I'll do a quick version here. I have to represent it, of course. I don't want to make a mess of it, so I do want to use straight lines. But we've done it a few times now, so we can do it really fast. So I have some stuff according to the first fraction. I don't need to make these big to understand what's happening here. Then I'm going to put that together with, oh, no, not pink. Together with, because I'm adding, can I write? Another rectangle, some more stuff. Now, if I prepared better, we would have had this already visible, but I did not. Now let's make them as effective as possible and go horizontal here, like we updated it. And I know that I'm going to have some of this already, 2 rows in this case. Now the question was, I'm not going to write out everything, so let me just make it clear here. This is not the full presentation for this kind of question, like in a test. This is just what would we have and how, excuse me, how does that lead me to the eventual shortcut when I need it, when numbers get more complicated. I can lead students to that discovery, even at this basic level. So what do we have? So at that stage, we want to be able to put these together. The sizes are not comparable, so we have to split them up in the opposite way. Oops, I'm blue, don't be blue. And this way. And here really is the thing. As soon as we do that, what have we done? What have we done when we use the other denominator and split it up in the first rectangle? For the second rectangle, use the other denominator and split it up in the other direction. Now we've created 12 pieces. By doing this, we've created a common denominator by making them comparable. And it's always going to be 4 times 3, the product of the 2 denominators. because I had 4 pieces originally, split that one into 3 pieces. That's exactly multiplication. How many pieces do I have? In the second one, I did the same thing, just the other way around. So the result's going to be the same. So what I've actually done here is converted this 1/4 to an equivalent fraction 3/12. This 2/3 to an equivalent fraction 8/12. And even though on the intuitive level I then did an integer addition, I just dropped the 12 and said 8 plus 3. So what we really did here was the shortcut just in visual form. We just didn't write it over a common denominator because visually it was done for us. Then we said 3 plus 8 is 11. How many pieces does it take to make a whole rectangle? 12. Therefore, our answer is 11/12. Now, I will stress again, it is on record, on video. I will quote this video if you say anything later on. This is not how you answer the test question. This is now when you're teaching and Timmy is ready to move on, drift towards more efficient methods. I'm showing how our basic rectangular method, there's sentences here, there's stuff happening, like always, that leads me to notice what we're really doing without the diagrams. If the numbers are more or bigger, less convenient, and I can't draw rectangles anymore, I can still imagine doing this. We're just not going to draw them. And then this is what we actually have. So behind the scenes, there is the suggestion of the shortcut, the more efficient methods that we can lead the student to with enough and appropriately chosen examples. Now the subtraction is going to be very similar. I don't even know if I need to do it. Let's just say we had them backwards because we have more blue than pink, right? So we can't subtract this one on the easy way. No negative fractions here. Then in the subtraction case, we did exactly the same thing. We might not have seen the second one, but we still had to create columns according to one denominator, rows according to the other. And as soon as we did that, we've created a common denominator. That common denominator is always going to be the product of the two denominators. And with enough examples, Timmy might see that, but wait a minute. It's always going to be the product. Why do I need to keep drawing rectangles? That means he's ready to move on to take a step to better understanding and more efficient methods. But he has to make that choice. We can't choose for him. He has to start with a number sense and then build on that. So in the case of subtraction, it's very similar. The method was almost the same. I just didn't show the second quantity because I had to remove it from the first. And when I then do the removal, it's just a minus here and everything is pretty much the same. Let me see a multiplication example. I don't have one written out, unfortunately. So we'll quickly have to do one to see what it looks like again. And when I get to these bigger ones, let's say 2/3 times, it doesn't even matter, does it? A quarter. Make it nice and simple. I have the first quantity, no, sorry, the second one, sorry, thinking of division. So let's represent that, and because it's 1/4, I need to split it up into 4. All right. And then let's color in what we have. We have 1. It's not nothing, but it's not much. So then our instructions are to get or take, or we get to keep, whatever words you want to make it distinguishable from the others. Use different keywords. Good idea. 2 of 3 rows. I can't use columns because I've used columns already. So rows is the obvious choice. And for that reason, I need to see 3 rows. Now, what have I done? As soon as I did this, what did I really do to the fractions? I again created a common denominator, or in this case, I don't want to call it a common denominator. I have created the product of the two denominators. Product of the two denominators. And that's why my answer is going to be over 12, because looking at this rectangle, it's going to eventually be a sentence. It takes 12 pieces to make a rectangle. That's going to be a sentence over here. And that's going to lead me to my answer with a denominator of 12, because of what I do in this intuitive process. Now, how do I get the numerator? Well, we get to keep 2 of the 3 rows. So we said yes, yes, no. So now, if this was maybe bigger, I would have more pink. Whatever this numerator is for the second number, the number that I have, the pink one, I would have that many columns, right? 1, and I have 1 column. 2, and I would have 2 columns. 3, and I would have 3 columns. I then take this many rows, which means I multiply the number of columns by 2 in this case. It's going to be the product of these two. So let me actually backtrack here. I should have been more clear. It's 3 times 4. And it's always going to be the product of the two denominators, my new denominator. And because of what I do in my basic method, it's always going to be the product of the two numerators. Now, maybe a couple more examples to convince little Timmy, because as I go from addition, subtraction, multiplication, and to division, they do get a little bit more complicated, maybe a touch less intuitive. So observing the pattern might need more examples until little Timmy is convinced. That's my goal. Because I know that this is true. I just want to lead him with inductive reasoning to that, which I know is a safe conclusion. Now, if you aren't completely happy with why is it the product, you have to be able to explain. Why is it the product of the top two? Why do I multiply the top, multiply the bottom? Why? Just because I'm used to it and I've stopped thinking about it, that's not a reason that makes it true. I can use my intuitive basic introduction method to multiply fractions to justify how these two numerators and these two denominators are put together to be able to find the answer without a diagram. So when the numbers get a little bit complicated, I'm able to step away from this and still find the answer. It's not the first step. It's not what we're going to do in a test, but there is a connection. These aren't detached, that when I want to get them to handle larger fractions, I just have to give them the formula and have them memorize it. No, I can justify it from their current understanding, from their fraction sense. We can discover this property, and that will mean way more. There is no blind memorization. There is just understanding. But some variety here to get them to see the pattern. Oh, it's always the top multiplied together. It's always the bottom. Oh, that discovery means way, way more. And then luckily we have some division, right? Let me just think, is this the best example? Don't want to work with that one. I don't like any of these examples. Yesterday's example was a good one. So let's make another one. Division is arguably a little bit, is the trickiest one to defend like this. Let's pick, let me just pick it backwards. Of course, if I have mixed numbers now, we run into the issue that when we want to be more efficient, we have to make improper fractions and stuff like that. That's a continuation, another step after this. So let me just set that up. We have 7 minutes. Why not? To see how this one feels. So I'm going to go thirds vertically. This one can be a little tricky to keep track of. So I want the first time I want the numbers to be decent. Hopefully this one is, could be. I have 2 of them, right? We want our first example to not be big or weird, but comfortable fractions. Okay, so then we said, like we've done 4 times now, our group size is going to come from a quarter of a whole. That's going to mean, whoops, not 2, but 1 of 4. It's going to have to be rows. Now, just because I am going to make 4 rows doesn't necessarily mean the same as it did previously. Because we're not going to do the same thing. Yeah, I do need to see the rows so that I can see my group size. Group size is 3 pieces. Okay, 3 pieces. All right. 1 of the 4 rows in a whole rectangle, 3 pieces. So now I need to fit it in. Now we're going to write the full sentences. We're just trying to, I just didn't have a nice example for my first attempt here. Fit in my group into what I have. Let's see it. Let's make it blue. Make it blue. There's one. There's maybe another one. 2. And I have some left over. So I can fit it in 2 whole times. Let me just think. Yeah. 2 whole times with 2 left over. I have a lot of 2's floating around here. That might not be ideal. Or we could say, excuse me, how many pink do we actually have? We have 1, 2, 3, 4, 5, 6, 7, 8. Let me write the have here. Have 8 pieces here, pink. And I'm trying to fit in groups of 3. So let's just maybe see the integer calculation. It's going to be 2 with a remainder of 2 as well. So I know my answer. I know my answer is going to be, I'm just going to put it up here in the corner here. My answer is going to be 2 whole times, excuse me, get all choked up about division. 2 whole times I can fit it in with 2 of the 3 that I need left over. Now in the case of division here, even the nice small fractions, the mixed number doesn't immediately show how to get these. I'll do the improper fraction, which is 8 over 3. And that then shows a little better where the behind the scenes calculation actually where it sits. The mixed number is very much a presentation thing. As soon as I step just a little bit away from the left intuitive side, mixed numbers really have no place. They're not efficient or clear in any way. They're a presentation thing that I use at the very beginning and then honestly never again. Whenever I want to do any calculation with any sort of efficiency, it's going to be improper fractions. But these are behind the scenes. I might not say it the very first time to little Timmy, because he's not ready for it at that stage. But the 8 and the 3 are behind the scenes, right? It is 8 that I have, 3 that I fit in. How many times can I do that? So these are equivalent, of course. Now the question is, of course, we only have one example. When we now think about this, you need a couple to have them see the pattern. So then the question is, where does the 8 and where does the 3 come from? Well, the 8 first. I had 2 columns of pink stuff. 2 columns of pink stuff. That is the numerator of the first fraction. 2 columns of pink stuff. I then split it sideways according to the second denominator, 4. And I've created 8 pink pieces. So it's going to be those 2 multiplied together. One from the top, the first one, and the bottom one from the second fraction. That is my new numerator in my answer. And it's always going to be. Then the group size. The group size. Well, I originally split it up in columns according to the first denominator. Regardless of what I have, it was 3 columns, my whole rectangle. Then I take a number of rows according to the numerator of the second fraction. And that if I had taken 2 rows of the 4, if that was a 2 and not a 1, I would have 6. 2 times 3. So those 2 get multiplied together. The 1 is a little inconvenient. It doesn't seem like actually anything has changed, but it has. And that's the denominator of my answer. Now, of course, division is more complicated. It'll take more examples to see the pattern here. Now, because I'm multiplying stuff, it's just a little up and down, little diagonal here. You can hopefully see that this is very close to multiplication. That I would get the same result if I just flip the second fraction and then do my multiplication straight across, which corresponds to fraction multiplication. I would get exactly the same thing. And do a few examples. Verify inductively that this is always going to work. Of course, it's not a proof, but we know it works. We're just trying to lead them to that discovery. So there's a lot of connections here that can be discovered by way of my rectangle method, by way of my number sense that I've built. And then when things get more complicated, I'm ready as little Timmy. I'm ready to let go of the drawing and trust my discovery and just take that further. But it has to be an organic, natural process, or it won't give me confidence. If I don't, but if I compare it to, if I compare being told something that I have to memorize and use it, yeah, I'll get used to it, I guess, because repetition does amazing things. But if I discover something myself, and for a moment at least, I'm going to think, I've realized something that no one else has. Look at this. Look at these connections. I could just use this and match them up and get the answer. Does anyone know about this? I don't need to draw any rectangles. This is amazing. And if I flip it, it's the same as multiplication. My mind is blown. For a moment at least, you think you're the only one discovering it. That is going to mean so much more, and I'm going to remember these things so much better moving forward. by having a more natural process of discovery. But it's up to the teacher to guide me to that. Instead, teachers just give them formulas to memorize because the teacher themselves, they don't understand anything. That doesn't make it right. That makes a bad teacher. We want to be better than that. And all these things are connected in so many ways. There's so much more we can do here and build confidence, remove all anxiety. There's nothing difficult about fractions if I take the right journey and the right approach. But I'll stop my rant there. Are there any last questions? Any last questions before we wrap up this fraction arithmetic portion? All right, then we will continue our discussion tomorrow. Thank you.